We've had a major breakthrough on our golden thread work that I'd like to share with you. Compartmentation is possibly the most critical measure to prevent the spread of fire and smoke. If just one of the assets that make up a firewall fails, smoke escapes and people can die. The location of penetration seals has always been a problem for asset management teams because there's often thousands of them, often hidden away in locations that are difficult to access. They need a space number for their CAFM systems, plus a simple plan that displays all of the assets that form the compartment wall. Contractors like Sentinel do their bit by providing meticulous records of what they install, but that's delivered as a PDF document containing hundreds or thousands of floor plans with pins on a floor plan image indicating the location of each individual seal. Don't get me wrong, this is brilliant data, but the asset manager will need to cross-reference hundreds or even thousands of drawings showing the location of individual penetration seals, dampers and fire doors to understand what assets are protecting each compartment. The golden thread's all about connected data, and there's a missing piece in this jigsaw puzzle. Each individual seal's X and Y coordinates. That's what we've just cracked. And it means we should be able to translate historic fire stopping reports into auditable digital records. We've used our AI and data engineering tools to read a 148-page fire stopping PDF, extract the data and location of every seal, and generate a 2D BIM model that can populate other applications, perhaps work order systems for statutory inspections, or any other applications. One coordinated version of the truth. This means we can apply AI to something that's otherwise very manual and doesn't really get done. Any application that can read and display COBie can now have interactive assets that can be viewed in the context of the whole building, but in a simple 2D BIM model that isn't cluttered with too much detail. A fire engineer can simulate walking from seal to seal to see it in context with the rest of the building and the other measures that are protecting the compartment. They can even pin them to 360 photos, but we can cover that on a separate session. The data from the Boris PDF report has been extracted into the database, so the information's at their fingertips. There'll be times when the detail on various drawings is helpful, so the user can switch on the various different plans, in this case compartmentation, as a background image. The interactive BIM model is still there, so any user can still click on the tags and see all the assets in the context of the drawings. They might want to check the entry in the 148-page report, so that's connected as well. We can now switch on the fire rated doors so we can check that they're right for that wall rating. We might even find that some of them don't need to be maintained as fire doors at all. This could save landlords and leaseholders a fortune and help asset managers in hospitals address tight budgets without compromising safety. The door schedules referenced an ironmongery schedule, so we've glued those together along with the installation detail. Each door is mapped to the manufacturer's product data, along with any documents. This reduces the risk of someone compiling an O&M uploading the wrong documents, and it's perfect for the new product passport legislation. If you want to know how some of the members of the task force can help turn O&M records into intelligent data, get in touch.